Good morning, everybody, and welcome to our partner webinar with BOS Balance of Storage Systems today. In this webinar, which is part one of three webinars which we're going to make, my name is Bob Hopman. I will give a short introduction, and Sean Lepoix-Devin from BOS Balance of Storage Systems will provide you with a lot of information about off-grid systems and how to get started with those. In part one, we will be discussing load assessment and site consideration. I will first start with some short webinar introduction, some information about this webinar and how to react. And then we will go into detail in the next chapters, a little bit about Victron Energy, and of course the main part, which will be helped by Sean, about the load assessment and site consideration. After the webinar, we will be able to answer questions and answers, which you can ask if you want to in the questions and answer section below in the Zoom webinar. The audience is completely muted, so there's no way to talk to us. Please ask your questions in this questions and answers section. We do not use the chat either. And this webinar is recorded. So in this case, in afterwards, we will be able to show you the webinar in an archive. Okay. First of all, a couple of slides to Victron Energy. We are a family-owned company in Holland, and we deliver power solutions for dedicated markets. The marine market on the left side is typically the market where we have been in for a long time. But of course, the stationary solar market, which we'll be discussing today, as well as automotive market, industrial market, home storage, which is nowadays coming more and more, and specific telecom systems are the markets in which we develop products for the system. Like I already mentioned, Victron Energy is a Dutch family-owned company which was founded in 1975. We are still a quite small and agile, competent team, which have a hands-on management. Our main focus is on R&D and sales. And of course, due to the fact that we've been working in the battery systems for quite a long time, last year we had our anniversary, 45 years anniversary. We have a lot of experience in battery systems and how to deal with those components within the system. We deliver a lot of trainings. If you want to, you can always find them on our homepage. This is also where you probably found this webinar. And we do also trainings in different countries, which is hand-on training with the customer themselves. If you want to do an online training, also here, we give a lot of information about our products online. So you can also here find more information how to configure components and systems. As a reference, I would always advise you to take a look at our blog. We have it linked in our homepage on top. You find it here. And you can subscribe to this blog. Here we inform you about new products, hardware, software, but also, as you can see here in some images, user experiences. So customers explaining about their system, which makes it more interesting to see if you have another solution for your market. Okay, this is already my part of the introduction. And therefore, I would now like to give the word to Sean, who will take over, and he will be discussing today's topic, load assessment and site consideration for off-grid systems.
Thank you, Bob. Hello, everybody. Welcome. Thank you very much for attending the webinar today. As Bob's already mentioned, today is about load assessment and site considerations. The other webinars that we have running in this series is the following Thursday, the 18th of March, and that will follow on from this webinar, which builds upon system sizing and selecting components. And then webinar 3 is a follow-up to an installation, so looking at after-service monitoring and maintenance. These presentations are designed for beginner to intermediate level off-grid solar installers, off-grid system designers, and just general persons that are interested in standalone power systems for residential and business applications. So the content itself is quite light, and 30 minutes should all be good. Okay, before I jump in, I might just, I'll start here. So a poll question, just to get our audience involved in today's webinar. What we'd like to know or understand is, where do you find the most challenging part of an off-grid system? Is that understanding customer loads, which is a little bit about what our presentation is about today? Is it designing this a safe and fit for purpose off-grid solution for your application? Understanding those loads and then turning that into a suitable system. Is it assembling the off-grid components and equipment, the physical wiring, the connections, the programming of the equipment for your system, or the after-sales service and support? That's what you find to be the most challenging part of an off-grid system. So what I'll do is I'll open up a poll, which we'll jump on right now. So you should be able to see come up on your screen now, give you those 4 options. So you can do that in your own time, but I believe once you clicked your option, the poll will itself disappear. So a quick introduction to BOS, and I'll also share my screen or share my video quickly, just so you get a look at my face. I won't keep this video on just because it can slow down bandwidth and slow down the webinar itself. But as you can probably tell from my accent, I'm Australian. I'm based in Adelaide, Australia, and I represent BOS in this part of the world. BOS is a German-based energy storage and manufacturing company, and as my accent describes, we operate globally, a lot in Africa, through Europe, and also increasingly in the Asia-Pacific region as well, and South America as well. We're a designer, manufacturer, and integrator of turnkey off-grid power solutions. As you can see from the images in the bottom right-hand corner, we use Victron equipment inside these all-in-one solutions. So we take care of a lot of the detailed wiring, complexities, and programming that go into or can go into building full off-grid systems. Our system capacities can be between 1 kilowatt up to 100 kilowatt capacity, and 1 kilowatt hour to 200 kilowatt hours of battery storage. And these systems can be used in a range of applications, from homes, businesses, schools, medical centres, government offices, and much more. So that's enough about BOS and myself. I'll quickly just turn off this video. So today's webinar, 4 quick steps that we'll look at. So the first is understanding what this customer or client wants and setting the expectations with them. So that's communication, really. So if that's verbal, over the phone, email, you really want to discuss very clearly what they're after, and make sure that we set the correct expectations. The load profiling, so we need to understand the energy and the power of what the system needs to power, or the project or the application. Once we know that, then we can potentially look at energy efficiency and load optimization of that site. So the less power that a site uses, the less solar and battery and equipment is going to be needed, therefore reduce the costs. Therefore can mean that the customers either can go ahead with a system because it's a lower upfront cost, or they're just going to be happier because it's a lower cost. And then finally, at the end, we'll quickly run through just a quick site conditions, things you should keep in mind when looking at a site. So electrical load profiling. And many of you may already do this, but it's good to ensure that we're all on the same page, and the important pieces of information that go into building the foundations of an off-grid system. So load profiling is the founding supports of any off-grid system. So without knowing an accurate load profile or the accurate energy demands of a site, everything that follows afterwards can be either not correct because you're basing system capacities on a load which may be too big or too small. So the importance of this step cannot be underestimated. So a detailed list, and I've got some examples of some load profiles in the next slides, just to give you an idea of what we mean by these points. So the electrical load wattage of all appliances, so that could be lights, computers, fridges, anything that needs power, and you know, if there's a not necessarily a wattage label, you know, volts times amps will give you your watts. The number of these loads, so for example, lights, you know, you might have 10 lights of 10 watts. I'll run through an example in the next slide. The hours of use for each load, duty cycles of fridges and air conditioners. So duty cycle, the terminology of that is, you know, a fridge is plugged in 24 hours a day, 7 days a week, but it only might operate, you know, 30% of that time. So if we times a fridge wattage by 24 hours, we're not going to get an accurate kilowatt hour energy usage factor. So taking into account certain appliances that's, you know, might be on for 24 hours, but they don't actually operate 24 hours a day is important to consider. And then with that information, then we can start to look at the total daily watt hour requirement. Watt hour, kilowatt hour, K is just the 1,000 times watts. And we want to look at, you know, that daily requirement, not a weekly or monthly average, because we need to know what it is for any particular day, not an average. So if we work on an average, but then there's certain days that might be higher consumption, we don't want to run out of power on those days because we've sized it for an average requirement. We also need to look at calculating or estimating the peak power requirements of a site. So what peak power refers to is the likelihood of multiple appliances turning on simultaneously. So if the lights were on, a pump started, the fridge and a few other appliances were all turned on at the same time, will the system have enough capacity to be able to handle those loads all turning on at the same time? So that's one of the key factors we need to estimate or calculate. Also, begin to get an understanding of what energy would be used during the day and what energy requirements are used at night time. So if we can understand, you know, if certain appliances or loads can be optimized for usage during daylight hours and reduce the nighttime consumption, that can have a positive impact on your system sizing and costs. And finally, consideration of summer and winter variances in load. So I know obviously here in Australia, and I'm sure it's very similar around the world, that there's different appliances operating in summer versus winter. There's different lifestyle or choices, usage of loads, and also the solar radiance changes throughout the year as well. So we need to balance out the summer and winter, both from a loads perspective, but also a solar generation perspective as well. But enough of just dot points. This is just a quick example of one method that we go about turning information from a site and putting it into a load profile. So listing each individual appliance, the quantity, the power. Whoops, sorry. So listing the power, the days per week, summer or winter energy, and we actually have a column in there of that duty cycle. So I think you can probably see the fridge there. In our instance, we've estimated that the fridge operates 30% of the time in summer and 25% of the time in winter. And that adjusts the average daily watt hour in the right-hand columns. And then all of those, or in this case, we've only got 4 appliances. It might be in some cases, there could be 100 appliances. Yeah, don't stop just because you've got just a few. We want to be as detailed as possible, and especially the bigger items as well. And then in the top right-hand corner, you can see the sum total of all these items. And I'm sure many of you probably understand this calculation, but I'll just go through it very, very quickly. Just to give you an idea of that LED lights example. So we've got 10 LED lights times 10 watts equals 100 watts, and they're on for 5 hours. So that will give us 500 watt hours of energy consumption. And similarly with the peak power load calculation, so we've got 100 watts, which is the LED lights, plus the 120 watt fridge, plus a 750 watt pump and a 30 watt communication system. That's equaling 1,000 watts or 1 kilowatt. What we haven't included in here is surge ratings and surge factors. That's probably a conversation for a more detailed presentation, in all honesty, but as long as you're considering these sorts of things, you're going to make a very good positive step in the right direction. So the next slide is about a case study, a project that BOS completed last year for the Kate Health Centre in Uganda. And using this as an example, we were able to get lots of very detailed load information from some of the doctors and representatives that work in the hospital. They took lots of photos of all their loads, of all the information about the site prior to us getting there, which enabled us to do the design very much remotely. They were very good at collecting a lot of information, the doctors and the staff there. And this is part of the load information that was generated from that site consultations, or from the people on the ground. So a little bit of it's in German, and it's in a little bit of a different format than that previous load profile showed, but this gives you an idea of itemizing each load, the room that it's in, the period of use, the number, and the wattage. So yeah, certainly can't underestimate the value of going through this process in a lot of detail and taking a lot of time. So once you have that information, the next part is, or can be used to reduce that load. So the simplest method to reduce system upfront cost and the requirements is to look for energy savings. So the less amount of energy that you need to build a system for, the less it's going to cost. And like I mentioned, generally speaking, I would think that your customer is going to be happier with a lower upfront cost as well. So some things can be quite straightforward, or I like to think so. If there's inefficient lighting in a property, replacing the lights with efficient LED lights can be a good starting point, because lights use battery energy as well. Anything that we can do to reduce the strain on the batteries is going to be good. And similarly with old inefficient appliances, I know it can seem not a good idea to replace a perfectly good fridge or even perfectly good lights or perfectly good appliances with something that's new, if they're working fine. But from an off-grid perspective, that old fridge might be using 2, 3, 4 times the amount of power as a new efficient fridge. And the cost to replace that fridge will be cheaper or lower cost than what it will be to upsize the off-grid system to power the old fridge. So I hope that kind of makes sense. That's yeah, don't ignore considering replacing inefficient appliances with new appliances, because in some instances, not all instances, replacing those inefficient appliances can work out cheaper in the holistic view of the energy solution for your application. Energy reduction strategies. So it can be a case of when the system is installed, or discussing with your clients ways they can use energy a little bit smarter. There can be smarts built into the system. So simple things, turning off appliances when not in use. It's amazing how many times I go to sites and there's so much left on during the day or at night time that doesn't need to be left on, and that's just using up a lot of power, putting unnecessary strain on your system when that energy can be used for other purposes, or again, to reduce the cost of your system. Load control. So for non-critical loads, we can adjust or turn them on based on solar availability. So if there's a bright sunny day, we can turn on certain things. If it's not a sunny day or the batteries are getting depleted during the day, we can switch off certain appliances or certain loads. That can be one way to work with the available energy from the system. Other things about installation of the off-grid equipment, but also equipment within the project. So in many hot areas, speaking from Australian examples, ventilation of the equipment, but also of fridges and other things to ensure that they're nice and cool, they're getting fresh air, can really reduce the energy consumption of, again, fridges is the perfect example, but there's plenty of other equipment that gets hot. And if it doesn't have good ventilation, it's working extra hard, which means that it's then consuming extra energy. And signage around the property as well, to again educate or try and instruct people who are using your system or the system to use it, or think about the broader impacts of how they use their energy. As kind of mentioned just earlier, we really want to try and maximize properties' energy usage during sunlight hours and bright sunny days, and we want to minimize the energy consumption at night time. So we of course don't want to, if there's critical loads and things that need to be powered at night, absolutely, that's what an off-grid system is designed to do. But if there is the option, or we can be clever or smart about shifting loads or being a bit more efficient with our energy consumption, we can make some savings. This really is a very basic graph, just what I mean by before, excess solar generation. The blue line is a typical energy use pattern in the sense that in the mornings and the evening is, for many applications, not all applications, businesses or healthcare centres may have a different load profile to this. This is more of a domestic home profile, but we really want to maximise energy usage in that yellow area and try and minimise where the sun's not shining effectively. That will give us the most cost-effective system. So again, back to our case study. In our instance here, we installed LED lighting, replacing inefficient lights that, as mentioned before, each light, there was, I don't know how many lights, might have been 50 lights, with a saving of 10, 15 watts per light, times by 12 hours a night, is a significant energy saving, which saved system sizing a lot. And also mentioned during the installation and post-installation, we held education with the healthcare centre workers and the staff members, just to speak about how they use their energy, where we can be a bit smarter, cleverer, and really that's the education played an important part as well. So information collection and the system sizing. So the information collection is really what I've been talking about here. We're collecting information about the loads. In the next slides, I'll talk a little bit about our site considerations and things like that. but yeah, we effectively want to record a lot of information that we're gathering from the customer, whether that be through email, over the phone, or hopefully if we can get to go to sites and visit a site in person, that is usually the best way forward. BOS has a collection template, which I'll run through very quickly next. And if you need assistance in this area, we're happy to supply you with this collection template. If you fill it out, send it back to us. We can help you into dimensioning and moving forward with a system as well. So this is just that very simple 3-pager information gathering sheet if you need help in this area. And finally, very quick topic on if you do go to a site and you're completing a lot of this, and it builds into when we're having our conversations with our customers as well. Where is the solar panel is going to go? Is that on a roof? Is it on ground frames? Is it free from shading? Trees, buildings, mountains. Can it be orientated and inclinated in the correct way for your location? Where is it in location to where the battery equipment's going to go? Because we're going to need to run cables from the solar equipment to the battery equipment. And again, on the battery equipment, is it expected to go indoors or outdoors? Is it near existing electrical switchboards or distribution? So if it's an existing site where there is an existing switchboard or electrical distribution, we're going to need to connect, or you are going to need to connect the battery off-grid equipment into the electrical switchboard to distribute it throughout the property. In most instances, we want to avoid direct sunlight on most of this equipment unless we're air conditioning it or keeping it cool. We want really good ventilation and security and things like this as well. So if you do go to site, take measurements of building roofs, distances between buildings, equipment room dimensions. I'm guessing that many of these sites are quite remote, so you might only get one chance to get to a site before you go back and do the installation. So I can't emphasize how important it is to get as much information as possible. Even if you think it might be irrelevant, just grab as much information, write it down. And information in that instance can be best done by photos. So take lots of photos, solar panel locations, the rooms, switchboards, photos of the entire site. Photos are, in many cases, gold for trying to design or plan out an off-grid installation. In this instance, the Kate Health Centre, these are some of the photos that we received prior to our installation, and here's a plan that was prepared as well. So this really gives you a good idea of the different buildings, where the buildings are located on the site, the distances between buildings, and also where solar panels, battery equipment, cables, and all that's going to go. So your very typical off-grid plans, but this is the sort of information that's is really helpful to make sure that everything's communicated really well. So that's it for the presentation. Actually, it is quite short, and I noticed we're up to 28 minutes for the entire presentation so far, and I see there's a couple of questions. I'll just see. Regarding the connection to the DC and AC load to the BOS system, that will actually be covered in next week's webinar. So next week's webinar will be discussing sizing, conceptualization, and a little bit about the DC wiring and AC wiring. And I can include some photos to give you an idea there. The next question, if customer has a grid supply and would like to use BOS as a UPS, will it be automatic switch between solar and grid supply to BOS? The short answer is yes, that is possible. So that's all good. I believe we're pretty much spot on our 30 minutes. So if you have any additional questions, feel free to send them through either now or in the email address below to me directly. There'll also be a follow-up email with the recording and things like this, which I think Bob will be able to help us with. So I might handball it back to you, Bob. Thank you very much.
No, thank you very much, Sean, for your very interesting and for important insights in load assessment. I think this is the biggest hurt in the beginning of planning on a solar off-grid system, and I think you explained many things about it, many important things, and hopefully all our customers that have been online for this webinar will come to the next one, of course, where we will discuss the system sizing and component selection, and yeah, and hope to see you again in the next webinar.